immune, but we are not talking about anything about human immune, but instead we are talking about the HIC, health and illness in community. Okay? So we will be continuing our lectures with the epidemiological designs. This is a continuation of our early topics on epidemiological designs. These are very important ones because you'll find these types of topics in the journals where they use this type of design, this type of method of carrying out the study. And so they are being carried out and they are being reported. So you as future physicians or future researchers, you must understand that how this type of study is being carried out. As we have been talking about that there are two types, basic. Number one is the observational, number second is the experimental. In the observational ones, types of observational designs, we had a descriptive one and an analytical one. Descriptive we finished, analytical one we completed one of the important designs, the case control. Now we'll be talking about another type of a design that is called as the cohort design. So before we go here, let me give me a big picture. Now what does it mean? If you get the big picture, it's very easy to remember. First, let us go back to the case control study. We started our study having cases, people who have the disease and people who are not having the disease. And we went back to find out the reasons for the disease, the risk factors for the disease. That was in the previous lecture. Now what we do here is something different. So there the first group was having the disease, another group was not having the disease, and we are going back. It was also called as a retrospective study. We started with case and controls. Now in this type of study, which we called as a cohort study, we have a group of population or a cohort. I will tell you what a cohort is. So we have a group of, or we have a population, and this population, we find out that there are two groups. One group which are exposed group, and another group which is not exposed. What does that mean? For example, we have you as students here. One group of you who do not smoke, they will be non-exposed group. And another group who are smokers, they will form another group. They will be called as exposed group, who have been exposed to some risk factor. And then what we do?
Second.
Welcome. So what we do then? With these two groups, we follow them up. We follow them up. So we start the study with a group of people who do not have the disease. Fine? Is that clear? But they have a risk factor, one group, and another group do not have the risk factor. So that's how we do it, how we start it. And then we follow up. That means we are continuously following them up for the development of disease. And during this follow-up, we also take, from the beginning, at the beginning, we take measure of exposure. That means how we can measure this exposure, smoking. For example, we have only smoking present or absent. Now we can also say that how many people in the smoking group take 1 pack per day, take 2 pack per day, take 3 pack per day. Okay. That's called how we say, how will we measure that? So we are measuring this exposure among the exposed group and then also among the non-exposed. Because you have to understand that yesterday you were living in Sakarta. Some people today are not living in Sakarta, they have died. And new people have come in. So this is not a static population which remains there. So similarly, a person who was a smoker yesterday may not be a smoker today. And a person who was non-smoker yesterday may be a smoker today. So that type of population is called the dynamic population. Is that right? One is static population which does not change. So here the population, when we talk about the exposure, we may take this exposure at the beginning or during the follow-up period. maybe some of them may have changed and become the non-smokers, means unexposed group, or some may have, from the non-exposed group, may have taken up smoking, become the exposed group. So we will be taking measurements and we'll be following them up for what? Following for the development of disease. So we will see diseased, non-diseased, here also diseased, non-diseased. This is called as the outcome. So 4 things are there. 2 groups of people, a group which has been exposed, another group which has not been exposed. So those exposed group, we say they have a risk factor. So what we are doing, we are measuring the risk factor, measuring it, then we follow them up, and then we see the outcome. The outcome means a disease or non-diseased person. For example, smokers, they develop coronary heart disease. Okay? So from here, if we have smokers, our disease will be coronary heart disease, no disease, coronary heart disease, no disease. Okay? That's how we go. So, it's clear from the diagram that our study starts here, and when we say follow-up, it goes into the future. In the future. So this type of study is also called as a follow-up study, a longitudinal study, or a prospective study. We go in future. While that study was called the case control retrospective study. Is that clear? So you see the difference between the two? So here we start with a normal population. Only thing is that this population is at risk. One of the groups is at risk, and another group is not at risk. We follow them up and see that how many of them develop disease, how many do not develop disease. So this is a big picture, that's what we do. Now we will go into the details. Is that clear? Yes, sir. Oh.
The follow-up occurs in the exposed or non-exposed?
Both. Follow-up used to be, otherwise how will we compare? We will let you know that we have to follow both the groups to see how many of those who have exposed develop disease, how many those who have not exposed develop disease. That is where we can calculate, we can find out whether those people who smoke, they have more chances, or those who do not smoke have more chances. That's how we say that this is a risk factor or this is not a risk factor.
Can we measure more than one factor in the exposed group?
That's what I'll tell you. Usually, when we design a cohort study, we initially determine that what we are going to measure. What is our risk factor? We may have one risk factor, we have more than one risk factor. Is that clear? So we'll come to know that how that happens. So first of all, what is a cohort? Let's understand it. Cohort is a group of people who have something in common. For example, all those first-year students who have joined this college will be a cohort. Or all those students who have joined first year of all colleges of Joff University will be called as a cohort. Study cohort. Or all the people who have been married, who got married during beginning of 2014 to the end of 2014. So people who are married in that, they also form a cohort. We call them married cohort, a marriage cohort. So cohort is a group of people which have something in common. Is that clear? So a group of people who have something in common. So this is why I say I bang and bang always, so that you will never forget it. Where will we talk about hair today? The hair. This is also called as? Well, as we said, we follow these patients. And these group of people do not have disease. Please understand. We are just looking that whether they will develop a disease in future or not. That's why it's also called a prospective study. In future we are looking. So we know that this is an analytical type of study, isn't it? It is undertaken to find out the evidence that this risk factor leads to development of this disease. That's what we are trying to do. We are trying to find out the association between a risk factor and the outcome. That means the disease. If there is an association, we try to find out how strong is the association. So first thing is there an association? Second thing is, what's the strength of association? We also did in the case control. So how we calculated the strength of association? What was the measure of risk in case control study? That was odds ratio. The odds ratio was the strength of association between the two. But we will see what is here the measure of risk. So other names for this cohort study are the longitudinal study, incidence study, fallout study. They are going into the future. We are going in the future. So important things which I have told you. So this cohort is important. They are free from disease. Case control, they were having disease. Free from disease. We measure the exposure. That means the risk factor which is among them, we measure them. Then observe over a period of time. So if you remember these things, it's very easy. Then we record the outcome. How many of them develop disease, how many of them do not develop disease. So that means the outcome. Then the study proceeds from cause to effect. As I said last time also, we say what is the cause of this disease, what is the cause of this disease, what is the cause of this disease. So what we are trying to find out is the etiology of this disease. So in case control study, disease has already occurred, effect was there, we were looking for the cause. Now here, it proceeds from cause to effect. So effect was there, we are looking for the cause, but here what is there? We move from cause, risk factors, to the development of disease. Is that simple?
Yes.
Or it needs anything more? Simple? So this is a very important thing. What are the basic principles of a cohort study? These are the basic principles. Very easy. It doesn't need anything. Huh? Now, this slide is important. It's a very important slide. And if you understand it now, even if you do not look at it, you can easily pick up what it means.
How do you measure exposure?
That's what we come to. We'll come, inshallah, in the future in this. These are the important points here. Now, when we should go for a cohort study? First, as I said, it's a prospective study. You may carry out the study for 1 year or for 20 years. Sometimes the investigator doesn't live for 20 or 25 years, he dies, but the cohort continues, the study continues to go on. One of the important cohorts is the Framingham Heart Study. If you have some idea about that, how they started, and most of the researchers, they have died, but study still continues. Study still continues. So, when the exposure is very, very rare, we take this type of study. And when there is a good association from the descriptive epidemiology that it generates hypothesis that this might be the probable reason for the disease. So when there is a good evidence, we proceed to this type of risk. Then, what is the other problem? Attrition. If you can, attrition of the study population can be minimized. For example, you have now this group, which I have made two groups, smokers, non-smokers. But the problem is, to all those people, I will be able to follow them up for the period which I am intending. I may be intending to follow them up to 5 years. So it's possible that everyone in this cohort, I will be able to follow them up to 5 years. Maybe more. Some people among the smoker group, they leave to another country. Some people who fail, they leave it. So when you are able to, that's called attrition. We call it loss to follow. The other word for attrition is loss to follow up. If we lose people to follow up, then we say attrition. If you can minimize, you have any problem, you can leave.
No.
You can leave. No. Come here. You cannot sit there. Come here. Or leave. Oh, ground is open for you. No disturbance. Sit here. And when there are sufficient funds available. You need funds, money for this. So this type of study consumes a lot of funds. It needs a lot of people, motivated people who will be with you as a group to carry out this type of study. So this is not an easy study, this prospective. It depends upon how much time. Maybe you may carry out for 20 years. We don't know. No. Some of our colleagues, they may leave the job and start doing business. I've seen most of the doctors even who graduated here, and then they are saying goodbye to medicine, they are picking up some other job. That's why the challenges come up. So we have a cohort, we have two groups in that, exposed and unexposed. Then we will see how many of the exposed one develop the disease, how many do not. Similarly, in the unexposed group, how many do develop, how many do not develop the disease. That is the basic idea. This is a big picture.
Can I do this figure for separately for retrospective or prospective?
We'll come to the types. When I come to the types of cohort study, I will tell you. For the time being, this is how we do it. This is a big picture you should keep in mind. So, when we table it, what happens? So we first identify those people who are exposed to smoking, who are not exposed to smoking. Okay? Now we have two groups here. I am writing here A plus B and C plus D. Then I follow this group and see how many of them develop disease. So exposed group was A plus B here. Now disease, A are developing disease, B are not developing disease. So A plus B is the total. So incidence of the disease is A divided by A plus B in the exposed group. Similarly, in the unexposed group, we have C plus D here. But when we follow them up, some people develop disease, some people do not develop disease. So the incidence will be C divided by C plus D. Is it easy or difficult? It's difficult. So we started with a group of people here, unexposed, exposed group, unexposed group. Then follow them up, we see people, some people develop disease among the exposed group and also among the unexposed group. Some people do not develop the disease, we can calculate the incidence of the disease. Is that simple? Or it means anything more? Any explanation or any query here?
Okay.
Is clear to all of you? So there are certain considerations when you carry out a cohort study. As I said, cohort must be free from disease. It's not a case control study, it's a cohort study. People are free from disease. They only have the risk factor. Both the groups should be equally susceptible to the disease under study. Means that both the groups, they do not have a variation in age, sex or other things, that those age or sex, they will be having a different risk than the different age group or the gender group. Both the groups must be comparable. So there should be, if you have male, so you should have male in one group as well as male in another group. If you have 20 to 50 years population, both the groups should be having the same population. And diagnostic criteria should be clear. That who you will say they will develop disease, how you will say they will develop disease, what is the diagnostic criteria for that. So these are the important steps. Now this is what you are asking, Saleh. So type of cohort study. Now we don't have a, this was a big picture, which I told you. And this was basically a prospective study, which I said, a longitudinal study. But you have other studies in the same, other types of the cohort, or the retrospective cohort. There's a new thing, huh? We didn't talk about that. Ambidirectional, both directions. It goes forward, it goes back. Okay? It's called ambidirectional. So, we have prospective type, we have a retrospective cohort, and you have an ambidirectional, which goes both ways, forward as well as back. Now, what is a prospective one? I will show you. So, prospective one is that the Framingham Heart Study, which was carried out, it started in 1948. So, people who are there, they selected the population from there, and they followed it, make the two groups who are exposed, who are not exposed, and then in future they saw that who among the exposed group and among the non-exposed group develop disease or do not develop the disease. So this is prospective. Now what is retrospective? But the problem with this is prospective, it takes long time. It is money matters, and people, you may lose people to follow. This is the problem with this prospective. And it needs a lot of funds, as I said. Now what retrospective is? It's also called historical cohort. Now what do? For example, you start a study here in 2008. You start a study here. But you identify a cohort a group of people from the records. So you go back and see 1998 in the hospital records. For example, you have people, females taking oral contraceptive pills, and you have another group, females not taking oral contraceptive pills. So today you are carrying out a study, so you are going back into the history and seeing that how a cohort, identifying a cohort who are taking a pill, who are not taking a pill. Then from the records of the hospital, you see the records of the hospital, 1998 up to this time. How many of them developed breast cancer? How many did not develop breast cancer? Not develop breast cancer. So that is how you can do, you can retrospectively identify a cohort and follow them up. Your study begins today, but the cohort is of previous 20 years back, and the follow-up remains the same. Because from there you are doing the follow-up. Follow-up is already done, but you are just analyzing that from the records. The problem with this type of study is that you don't measure yourself. In prospective, you are measuring yourself. Here you are taking from the records. Records have been taken by some other person. He may not have correctly put the data. That's the problem with this. So same thing will happen. So we are following them, but the study is from previously. So we identify that retrospective cohort. Now, if I identify the cohort here, part of it goes back, part of it moves forward. Or I can start it here, but start the follow from 1998. I identify them here, follow them here, how many develop today, and how many will develop in future. That's ambidirectional, both directions. I'm carrying out the study. So now what are the advantages and disadvantages? In a retrospective cohort, which we said, the information may not be accurate. It's not accurate. And it may not also be complete. But if you are doing a prospective, because you are doing it, you'll be taking yourself measurements, so it will be more complete, it will be more accurate. Because here, some other person has mentioned the data in the case sheets. It's not you. So it will be less complete, less accurate. Then emergence of new exposure. If something new exposure happens to this group, you cannot find it from the retrospective cohort, but if you are following prospective study, if you are doing a prospective cohort, then you can identify if any new risk factor emerges in them. Not from here. So expenses is more costly. It's less costly. So you can even do this type because it's less costly, but the compromise is on the quality of the data and the completeness of the data. Then you can complete it in a shorter period of time. Here you may need 20 years, 5 years, depends how much you want. Is that clear? Is that clear? Yes. Good. You may choose some study to do like this, some of you. So in a cohort study, the steps are, as we saw the steps in the case control study, we select the population.
What about the third one?
Ambidirectional.
Yeah.
So I said.
What of them?
It was only two. The retrospective and prospective.
Yeah.
The ambivalence, or what we say is ambidirectional. We start today, go back, identify the cohort, follow them up to this, and then follow in future.
Yeah, so I'm doing both of them.
Both of them. Retrospective as a retrospective. But again, the retrospective part, it will be less accurate information. It will not be complete information. That's the problem.
Yeah.
So the steps in the cohort, how you will carry out a cohort. If you are doing a cohort in your own research projects, what you will do? So selection of the population cohort, you will select it and divide them into two groups. A group which is exposed, a group which is not exposed. So they don't have a disease, please understand. They are apparently healthy people. Then you follow them up and measure the exposure. I will come to you, measure the exposure. For example, if you are talking about smoking and non-smokers. Now, among the smokers, I will ask them question, how many cigarettes you take per day? Or how many packets you take per day? So that is the exposure. I measure it. Are they taking one pack Are they taking 2 packs? Are they taking 3 packs? You got my point? So even in the exposure group, we may have different categories of people. And the other group, they don't take cigarettes. So this is how we measure it. Even on history. Sometimes you need a sample to see how many of them are exposed, how many of them are not exposed. It depends on what type of research question we have in mind. That will determine that how we will take this measurement. If you are taking a measurement that those people who are in medical college, how many of them, because of stress, develop hypertension, how many from law college develop hypertension. So the measurement will be blood pressure number 1 and stress level. So you will distribute questionnaire and see how many people are stressed. And in this group, how many people are stressed in that group. That's how you can measure that exposure. And finally, you do an analysis. And the table I have shown you, that will follow the group up and measure the incidence rates. Which one? First, selection of study population. This population, we divide them in 2 groups. A group which is exposed, a group which is unexposed. But if you take only a study population exposure group, then you have to find out an unexposed comparison. That's why I put in 2 steps. Otherwise, it's 1 step only. General population, exposed, unexposed. So where from you will take the cohort? As I said, cohort is a group of people who have something in common. So you can take from the community itself. You can take exposure cohort, for example, radiologists who are working in the hospital. You can take them as a cohort to study that how many of them will develop a blood cancer in future. You may also take physicians, another group, who are not exposed to that type of work. You will also see how many of them develop. So, based on a particular type of exposure. Or a birth cohort. Like I said, you are a birth cohort. You are a birth cohort. School, you have entered this medical college, you are born somewhere back, maybe of the same age, hopefully, and you are here. So school entrance can also form as a birth cohort. Then we have occupational cohorts, some people who are doing some particular type of work. So they can be a cohort, they share some common thing. So these are various types of cohorts which you can have for the study. Obtaining data on exposure. How will you measure that? A review of records, if it's a historical one. If we are carrying out a historical cohort or a retrospective cohort, we have to take data from the records. So from like the dose of radiation, kinds of surgery, whatever you want to see there. What will be your research question? Depends. That data you will be extracting. Or you may do some medical tests. Then, or environmental surveys sometimes we need to carry out for the exposures which are related to the environment. Then once you do that, we need to have a comparison group. The comparison group may be within the cohort who are exposed, those who take half pack, 1.5 pack, 1 to 2 packs, and then we see number of deaths among them. So they will appear as controls for each other. But these are exposed. So you may have an internal comparison, or you may have a group who do not smoke at all. So that will be external comparison. That will be external comparison group, which you can compare the development of disease among those who are exposed, among those who are not exposed. Among the exposed, you can have subgroups, those who take less number of cigarettes per day, who take more cigarettes, follow them up, see how many among those 2 groups develop. So that's called internal comparison. If you compare non-smokers and smokers, that will be external comparison group.
So the comparison between healthy and unhealthy, for example?
Huh?
Comparison between the cohort and healthy people?
Cohort are always healthy. Cohort is a healthy group of people. I said they don't have the disease. So in that cohort, you make 2 groups based on exposure. Some of them are exposed to a particular risk, some are not exposed. So this unexposed group is a comparing group. So we are trying to find out how many of those who are not exposed develop a disease, how many of those who are exposed develop a disease. So what we are trying to find out, that does this exposure increase the chance of disease? That's what we are trying to find out, the causal relationship. Then we follow up this group. So we have done these steps, then we follow up this group. And please understand, when you follow up, you have to follow equally. Those who are at risk and those who are not at risk. Both of them have to be followed. For example, if today I have a group of females who take oral contraceptives and another group who do not take oral contraceptives, because those females who take oral contraceptives, they are health conscious. They may come repeatedly to you for follow-up. Or the physician may prescribe them to have mammography at regular intervals. Then those who are not exposed, what should they do for the unexposed group? So, in order to make decrease that bias, that's called measurement bias, you have to have equal surveillance, equal opportunities for follow-up for unexposed as well as exposed. Then only you will get a true picture. Otherwise, there will be confounding. That's confounding. Measurement bias here in the cohort study. So the procedures can be the same. Number of things you can do to measure that exposure or the development of disease. Then analysis, what you are measuring then at the end of the day? A cumulative incidence risk or incidence rate outcome among unexposed and exposed. Now here I want to tell you one thing, that you have two types of cohorts, as I said. This is time. So here you have recruited a cohort. One cohort who have exposed, unexposed. Then you follow them for example 5 years. So you follow them for 5 years and see how many among them develop disease, how many among them do not develop disease. For example, those who are exposed, there is a disease. So 2 people develop disease, and here 1 person develops disease among unexposed group. This type of cohort is called as a fixed cohort or a closed cohort. So there is a simple difference between fixed and closed cohort, which I will not tell you because this is not the form for that. So that is a fixed type of cohort. But sometimes what happens that your cohort is like this. So females who are taking oral contraceptive pills, some females they start today because this is your date of study and you go into the future. So they started today and you are following them, for example, for 20 years. Some did not start here, they started somewhere here and you are following them for the same period. Some people start here, some females. Because they are not starting, all of them are not exposed at the beginning. They get exposed at different types of time. In other words, you are recruiting people at a different stage of time. So when this thing happens, this is called fixed. That was fixed or closed cohort. I will say the difference between. But here this is called as open cohort. Okay. Now here they have equal time ups. They are equal time. Here there is not equal time up. Some are coming here, you are not following them equally. You are starting here, some are coming here. And study ends here. Some enter here, study enters fixed. Here it ends. This is study ends. Now what you do with this? So what you will do is person time of observation. So persons, for how much time you have observed it. This is called as person time observation. Here we have equal number up to equal. But here we don't have equal number up to equal. They enter in your study at different times. So there you calculate person time. And there we calculate the cumulative incidence risk.
You have to mention how many persons starting from this day and they will develop the disease or not?
Yes. So we consider their person time. That means how much years of follow-up has been done if we consider 1 person. But if we consider 100%, how many years we have followed? His person time. Closed and open type of cohort. We will come to that also. So the incidence rate, sometimes you can go for a cumulative incidence. If the disease is a very acute disease. So in short period of time you are getting the cases. Short follow-up like outbreaks, or you may calculate incidence density. over a period of time, it's a chronic disease. And when the follow-up periods, in such cases, the incidence density is appropriate measure. So how are they different? We can talk at length when we talk about the measures of risk. So here you have to only see that we either calculate the cumulative incidence or we calculate mean. So it's like this. So we have two groups, exposed and unexposed groups. So A plus B here, C plus D here. Some people are developing disease among the exposed group. Some people are also developing disease among the unexposed group. These are deaths, sorry. These are deaths. There are no deaths. Then we calculate the outcome, deaths per, like here, incidence rate will be A divided by A plus B. Similarly, C divided by. So this will be incidence of death among those who are exposed. This will be incidence of death among those who are unexposed. Now, so this gives only the incidence rate. Now the question is, does this risk increase does this exposure increase the chances of death? How will we calculate that? How will you do that? So this gives only the incidence rate among the exposed groups and among the unexposed group. But if I have to see that exposure increase or decrease the risk, then what should I do? We will divide this figure, divide by this figure. Now I will tell you how it goes. So I have told these ABCD. What's ABCD? So what we will be doing is risk in exposed group. A divided by A plus B, we divide them. C divided by C plus D is the non-exposed group. So when we compare that, we get something called as the relative risk. So the measure of risk in a cohort study is the relative risk, or it's also called as risk ratio. What is the risk of dying among those who are exposed to those who are unexposed? That's called relative risk. It's very simple calculations. So we'll give an example for that. That's much better. For example, we started with the children who are less than 12 years of age. So we recruited them, and we made them two groups, identify two groups. One group where the parents were smokers. So the children were also exposed to secondhand smoke. And here, family were non-smokers. So we have the cohort of 1,000 children of less than 12 years of age. One group where the parents were smoking, another group where parents were not smoking. So this group was called, this group of 500 children were called exposed group. This was called unexposed group. Now we followed them up. That how many of these develop a respiratory tract infection, how many do not develop. Similarly, from this group, how many develop a respiratory tract infection, how many do not develop a respiratory tract infection. What are you getting here? What are you getting?
Disease 300. Disease 200.
What is the idea? So it tells us from the picture, we see that those who are exposed. Is there anything to love?
No.
No, I shifted you many times, and I will push you out and put a
He
report.
said this is 300.
Which will lead to your expulsion from the college, let me tell you frankly.
Okay.
There's nothing, we are not doing any monkey show here. If you are not interested, you can leave. If there's anything to laugh, talk to me. I will also laugh with you. There are two groups. From here, we are clear that those who are exposed, they have more chances, more children are developing the disease. Now, I will calculate two things. The incidence rate among this, the incidence rate among this. So what is the incidence rate among this?
300.
300 divided by 500. And here?
120.
So this will be incidence among exposed group. This will be incidence among
Unexposed.
Now, how I will calculate the relative risk? Incidence among them divided by incidence. Now, let's see. Let's see whether it's correct or not. So, 300 divided by 500 means 6% they develop this disease. And from here, 24% among the non-exposed develop the disease. So, this you can easily calculate, isn't it? then we'll go ahead. So what was the risk ratio? So those who were exposed, do they have a high risk or not? So we divide the 60 incidence among exposed, which we calculated, divide by incidence among unexposed, we got 2.5. That means those children who were exposed, where the family was family were smokers, they have 2.5 times more risk of developing a disease than those who were not. That's how we see that if smoking causes more health problems or not. Is clear? Yes. This is also called as risk ratio or relative risk. So here the measure of risk is relative risk or risk ratio. And in the case control, it was odds ratio. In the last. So that are the measures of risk. So if anybody tells you what are the measures of risk, at least this time you know there's something called as odds ratio in case control, and from cohort we can develop relative risk or risk ratio. Then we will go to another two important parts. The other two risk measures of risk. Now what are those? One is called as difference. These are called difference measures. One is called attributable risk, and one is called population attributable risk. Okay, now we'll see what that means. Attributable risk means that the number of cases in the exposed group, which were 300, and unexposed group were 120 cases. In our example, number of cases the exposed group that could be eliminated if the exposure is removed. So we will say how many people were having this? 300 minus 120. How much it comes? 180. So if they were not smokers, we would have less problems. So 180 cases would have been less if there was no smoking. That's called as how much you will attribute to that cause, the smoking as a risk factor. You are attributing 180 cases to those families who are smokers. Another part is population attribute.
180
cases. They would not have developed.
If their family
was not smoker. If we remove the smoking, that means 100 cases would have been less, because they were not smoking. So only 120 cases. They are smokers. Their parents are smokers. So overall, 180 cases are more among smokers. So this could have been decreased if smoking was removed from the family. That's simple. That's not rocket science, no. Very, very easy. Then there's another thing called as population attributable risk person. So how we do? Incidence among population, incidence among exposed divided by incidence among population. Now I'll tell you how that is calculated. So in exposed group, we have a higher incidence. In unexposed group, we have a lower incidence. Now, if I will draw a line here, so this part was because of unexposure. This part is only because of that exposure. Attributable risk, which you can attribute to the cause. Is that clear?
Yes.
You see here? Yeah. So this part is common to both. This could have been occurring even if because they are not smokers. So this would have still occurred here if they are non-smokers. This is the only part which is attributable to smoking. So this is called incidence among exposed minus incidence among unexposed. This part is the excess part because of smoking. This is the excess prevalence, incidence because of smoking among families of children who have respiratory tract infection. So, how we do that at the end? So we have lung cancer cases, yes, no, smoking, yes, no. So we had 2,000 smokers who were non-smokers, 8,000 total. So 100 developed from this 2,000 and 80 only among 8,000. So the incidence was here, you divide it, incidence rate, this divided by this divided by this, it comes 0.1. So if we see the risk difference, we minus it. So 0.05 minus 0.01, it comes 0.04. So this percent of cases you could have easily stopped were they not smokers. Now what's population attributable risk? So this is the excess risk means that if you remove this thing from the population, how many cases will be decreased in the population? At the population level. This was individual level. Now at the population level, what will happen? So this is the unexposed, exposed population. The above one is the attributable risk, which we discussed. So the population attributable risk, this is the population now. This is the total population. So what is the incidence in the total population? 0.018. What is the incidence among this? This divided by 2000, this was equal to 0.050. When we divided this, it gave us in the unexposed. This is for the total population. This is called as population attributable risk. What we do? So, incidence among the population, we minus incidence among the unexposed group, that comes equal to 0.08. Now, population attributable risk, we divide it by 0.018 among the exposed group, multiplied by 100 means 44% in total population. That was among the groups. This is among the total population. Conclusion is that 44% of the lung cancer in the population could be prevented